Rahali. I am 37 years. I am a student of Faculty of Technology, University of Msilia, Algeria. I am from Algeria. Hello, I am glad to present my research works, robust leading mode control via type 2 fuzzy logic for double star induction motor. Introduction. The major disadvantage of three-phase asynchronous machines is that they remain limited in power, and the growth of electrical energy consumption and high-power electrical application. One solution is to use high-phase number machines. The double star induction machine consists one of the multiple machines. So it's used on application requiring high power such as electrical vehicle, locomotive traction, and naval application. Problematic. Then in the past several years, sliding mode control widely used because in effective control strategy on modern control and to obtain good dynamic performance, robustness, and sample realization of control system. The major drawback of sliding mode control is the shattering phenomenon. So, the hybrid fuzzy type 2 sliding mode control used to approximate the discontinuous control and reduce the shattering phenomenon. Based on this objective, we present our work of the following plan. First, we present the DSME modeling. Then we present the design of the type 2 fuzzy logic sliding mode control. Then we go to synthesize the control strategy. After the results and discussion, we end with our conclusion. The principal contribution of this paper applied to double star induction machine, whose purpose is to control the speed, flux, and currents of the double star induction machine in order to solve the problem of trajectory tracking and the presence of uncertainties with minimize the phenomenon of the shattering phenomenon. So, the double star induction machine is composed of two separate stator winding with a fixed three-phase winding and standard sample squirrel cage rotor, composed three rotor phases moving similar to that of the conventional asynchronous machine. The two stators are effaced from each other by angle alpha equal p of 6. Their axes are shifted from each other an electrical angle equal to 2p of 3 with isolated nature. The state equation for double star induction motor and the Park reference are given by equation 1. So, type 2 fuzzy logic sliding mode control design. The sliding mode control comports two terms, namely equivalent control term and switching control term. So U is equal to U equivalent plus U S. U equivalent is equivalent control, and U describe the discontinuous control. In this work, the described command on sliding mode can take the form of the following expression 3, where K is positive gain, is sliding gain. The main idea of fuzzy sliding mode control is construct set of fuzzy rule based on the physicalized distance. The following figure illustrates such concepts in which three labels of fuzzy sets are assigned to the sliding variable surface S, negative B, 0, and positive B. For the control of output UF, the label of the fuzzy sets are also 3. negative peak, 0, and big positive peak. The last step is the diffusification. After the determination of the membership function and the phasis rule, which is the procedure to determine a crisp control for UF. Among the possible structures of sliding mode controller, we have proposed the following structure: UF equal mod K sin S surface of flux. We define the following rule. If S surface is negative, then UF is negative. If S is 0, then UF is 0. If S is positive, then UF is positive. The objective of the controller is particularly in the attenuation of the shattering phenomenon, obtain a robust performance control. The regulator of the speed, the flux, and the force current are substituted by sliding mode regulator, an equivalent control part, sliding mode control, and a phase control part, FLC. The block diagram of the proposed type 2 phase sliding mode control is shown in following figure. What is the speed control. This is flux control. This and this and this. See the force, current, EDQS1, EDQS2, EDQS3, and EDQS4. The synthesis of the hybrid phase sliding mode control, type 2 phase sliding mode control with a sliding surface can be achieved in two successive steps. Step 1, the speed control. The surface of the rotor speed SW is equal W reference and W reference month W rotor. We take EQS1 plus EQS2 is equal EQS. Finally, the equivalent control is given by EQS equivalent given by the following equation with EQS n is equal by the following equation. The same thing for the flux controller. The surface of the flux S phi is equal phi reference month phi rotor. Finally, the equivalent control is given by this equation with EQSN is equal the following equation. The second step for new error of the component of the stator currents is given by this equation. Dans result en discussion, the dynamic response of speed, electromagnetic torque, and dq axis current is given as the following figures. For this speed, the speed response and the short time to research is reference value at 0.4 seconds. With that excellent, and it's also grant a better continuation as well as quasi total rejection of the perturbation of the increase of the load. The application of the charge from time t equal 3 seconds generates increased electromagnetic torque and stator current. We have positive influence of the torque that increase to cap the speed flow its reference value. The response of the current of the key axis switch control of the torque is similar to electromagnetic torque, whereas the current of the axis day with control the flow of the rotor remain constant. The comparative study was opted for a comparative study that will allow you to conclude on the performance of the control law developed for DS double star induction machine and other. This study is based the following two criteria. One, the energy of the command presented by G1, the sum squares of the error presented by the G2. From the result present in table 1, we can conclude that the sliding mode control combined with the type 2 fuzzy control is in general the most efficient from the point of view minimization of the two criteria. Conclusion, the speed adjustment par type 2 fuzzy sliding mode brings remarkable improvement because the type 2 fuzzy sliding mode control regulator offer good static and dynamic performance, shorter response time, and no overshot, high accuracy, good stability, simplicity, and robustness. This result confirms the high performance of the proposed control, demonstrate robustness under various operating conditions and assure global stability of this machine. It is considered a major step in the evolution of intelligent control. Thanks.
Yes, thank you so much, sir, for this wonderful presentation on doubly starred induction motor. So do we have any questions for Hilal, sir, from participant side? Any questions for Hilal, sir? Sir, I have a question regarding this PID controller, sir. Sir, can you hear me? Hilal, sir?
What?
Yes, sir. Sir, like, have you done any practical implementation of this fuzzy logic driven PID controller for the induction motor, sir? Or is it just the theoretical and software analysis?
Analysis of this?
Yes, sir. I'm just asking, have you like tried it practically, this PID controller with fuzzy logic along with the doubly starred induction motor? I'm just asking. So was it like, did you implement it in the machine itself? Like, did you try and did you get the same responses as per your like the software reports?
The fuzzy logic.
Yes, sir.
For sliding mode control presented in the second term, US. US is sounded by fuzzy or fuzzy logic control for ameliorate the performance of this machine. The current or the speed and the flux of this machine, the six parameters, is changed by regulator fuzzy for améliorer the performance of DSM or bien double star induction machine. So
okay, sir. Fine, sir. Good work, sir.